Hello everyone, we've reached the third chapter in the ComfyUI Advanced Understanding series. This is where I go back to basics and try to explain how Stable Diffusion and ComfyUI actually work. If you haven't already, also check episode 1 and 2. So today's topic is upscaling, but to understand upscaling we need to talk about control nets. And before that, we need to understand how noise actually works. Before I begin, you probably noticed I have this bar at the bottom instead of the classic side menu. If you like it, you can activate it from the settings and enable the beta menu from this drop-down. Okay, I've set up this workflow with a KSampler Advanced that generates Christmas decorations. If I set the return with leftover noise to enable, I can see the noise at any given point of the generation. Let me set the end at step to 1. So this is the first step, and it's quite fascinating to think that this noisy image has already inside all the information needed to generate the final picture. If I increase the end at step, we can see the image slowly forming. At step 10, we already have all the elements. But what if I could influence how the noise is generated? Well, I actually can. If I set the end step to 0, I get this brown image. Now I load the scribble that I prepared and send it to the latent space and to the KSampler. This way, the generation will start with the noise I created instead of an empty latent. If I set the end step to 1, my image is completely obliterated. But if I go to 20, you'll see that I was actually able to drive the generation. Let me add a repeat latent batch node and repeat the noise 4 times. And as you can see, the result is very consistent. This is basically the most rudimental of the composition conditioning and can be very useful at times. For example, let's say I want to create a frame made of stones. In the prompt, I can try a frame made of stones, moss, and climbing plants. I connect an empty latent, set the batch to 4, and see what happens. Well, this is not really what I wanted, so I can use this image as reference to drive the composition. Then I open the mask editor and select roughly around the edges. Now I need a set latent noise mask, connect the latent and the mask, and finally to the KSampler. If I generate now, I am much closer to what I wanted. This one is pretty nice, for example. Let's try another seed, and as you can see, it's pretty consistent. And of course, it would get better with proper prompting. Okay, we've seen how easy it is to alter the generation with just one initial frame. What if I could manipulate the noise during the whole sampling process? Well, that's what control nets are for. ComfyUI has 2 main control net nodes: Apply ControlNet and Apply ControlNet Advanced. But for once, things are simple. Just use the Advanced. It's the one I use 99% of the times. There's actually a third one called ControlNet Apply SD3 that is specific for SD3, of course, but it works the same way as the Advanced. So there are dozens of control nets, and I can't possibly cover all of them in one video. But they all work the same way, so once you understand one, you can use all of them. In this workflow, I have prompt close-up illustration of an anime girl with short blue hair, and this is the kind of images it generates. This is nice, but I want the girl in a specific pose. A very simple and fast control net is Canny. So I'm loading the image reference with the pose I want, this one. Then I need to pre-process this picture so the control net is able to read it. In this case, I'm using a Canny preprocessor. If I connect the image and preview, we can see what the ControlNet is going to process. Okay, this is fine, but maybe we need a bit more details. So I'm lowering the first value to 0.2 and the second to 0.6. I connect the image to the ControlNet, then I need to load the actual model with a ControlNet model loader and select Canny. There are many options for SD15. If you don't know where to start, try with ControlNet++ models. All left to do is to connect positive and negative and back to the ksampler. Now, strength 1 is generally too high. We want to give the checkpoint some freedom. A good starting point is 0.7 if I want a strong conditioning, but it still leaves some leeway to the model. Okay, I think we can generate. And there you go. Now we have our anime girl in the pose we wanted. The girl also got some of the feature of the woman in the reference though, so if I want a stronger anime style, I can lower the strength quite a bit. And now the head position is more or less the same, but the generation follows the prompt better. The problem is that we lost the back and the shoulders position, and we can try to fix that by playing with time stepping. I can set the strength to 1, but stop the influence of the ControlNet at 40% of the sampling. So n% 0.4. If I generate now, I should get still a nice anime style, but a pose close to what I wanted. Yeah, it seems to work. I can try to lower the strength a little and increase the n%, and this is pretty nice, but we can try to do better. So I want the model to follow the prompt very closely at the beginning without any interference. That will give us a strong anime style, but then I need the ControlNet to kick in and force the composition as per the reference. To do that, I can set the start % to 0.15 and % to 5 and very high strength. Let's try 0.9. Now, this is not mandatory, but if I start the ControlNet at a value higher than 0, it might be a good idea to select a stochastic sampler like DPM++ to MSDE or Euler Ancestral. That is because with a not converging sampler, the model has more freedom when moving from one step to the other, so we have better chances to get the right position. And finally, this is exactly what I wanted. I understand it can be confusing at the beginning, but you can think of the strength of the ControlNet as a sort of blur filter. If you set a low strength, it is like sending a very blurred image to the ControlNet, so the model won't be able to see all the features, and it is free to interpretation. With time stepping, you can send a very strong conditioning at the beginning, and since the initial steps are the most important, the composition will be set loud and clear. But then you leave complete freedom to the model that has time to converge towards the text prompt. By mixing strength and time stepping, you have a very powerful tool for ControlNet fine-tuning. Okay, I guess this is a good time to talk about workflow tidiness. I know I'm not good at that, I'm always in a hurry and I don't have time to make the workflow fancy to look at, but it's important to keep them nice and tidy. This is a very simple workflow and it's easy to follow, but we can do better. First of all, try to avoid packing nodes all together for the sake of having everything in one screen. It might seem a good idea, but you can't actually see the pipe connections and you are forced to move everything around to understand what is going on. So ideally, all the connections should be visible at first glance. Then we should try to avoid overlapping pipelines because, as we know, crossing the streams is bad. It's not always easy, but using reroutes, it is usually possible. In this case, for example, I can use a couple of reroutes for the VIE and the model too. Now I can bring the ControlNet below, resize a few nodes and tidy up a little. And this is finally an easy to follow workflow. We have a couple of overlaps here, but they don't compromise readability, so I'd say it's fine. So do as I say, not as I do, and keep your workflows well organized. Okay, back to ControlNets. We've put a lot of effort in trying to get the pose of the reference, but not the style. Maybe a better option could be using a pose ControlNet. I need a new preprocessor. In this case, the DW pose estimator should do. If I connect the preview, I get this stickman. As you can see, the shoulder position is not great, but let's give it a try. I need to select the OpenPose model, connect the preprocessor to the ControlNet node, and I'm keeping the previous generation to check the difference. I'm also setting the sampler back to DPM++ to M and the strength to 0.7 with no time stepping. So this time we had no issues keeping the anime style, but the model was not able to catch the pose properly. This is just to say that the most logical ControlNet to use in a particular situation is not always the best option. In this case, Canny did a better job. Okay, let's see another use case for the pose ControlNet, this time with full body. I'm setting the resolution to 512 by 768 and the batch size to 1. I don't need the phase from the preprocessor because the model should be able to understand that already. And I want a realistic picture this time, so I'm selecting a realistic vision checkpoint. In the text prompt, I'll have beautiful blonde woman standing wearing a fashion pink dress. Okay, if I generate, I get something very close to the original, even though we would need a second pass to get better details. Now, in this picture, the model is a bit skinny, and I like some meat on those bones, so I can add chubby in the prompt and see how it goes. Okay, this is fine, and I can probably do better by playing with the strength or time stepping. But in this case, the original shape from the preprocessor is constraining us a little. It's important to remember that this image is not set in stone and we can play with it. For example, I can add an image resize node, set the width to 672 and height to 0. If I preview now, the pose will be slightly stretched horizontally. And if I send this to the ControlNet, the model will more gladly do what we asked. Since we are here, let me also try to use the same dress of the reference. For that, I'm using an IP adapter advanced, the unified loader, and I'm using a standard model because I need a very light conditioning. For the same reason, I'm setting the weight to 0.45. Finally connect the reference and the model pipeline. And there you have it. This can be improved with attention masking, multiple IP adapters, and of course detailers, upscalers, but I'll leave that to the diligent student. Okay, next, Tile ControlNet. This is very important because it will pave the road to upscaling. Tile is basically a color transfer. In this workflow, I prompt a cyberpunk scene and I'm sending the Mona Lisa as reference. Tile doesn't need a preprocessor as we are using directly the pixel values. I set the strength very high, but the influence stops at 40%. So if I generate, I get a very loose resemblance to the reference, but a strong style coming from the prompt. If I set the end% to 0.8, I get closer to the Mona Lisa, and if I want to get even closer, I can first of all ensure that the image is 512 by 512. Then I send it to the latent space and finally to the K-sampler. At this point I can lower the denoise to calibrate the effect. I can try with another picture and see what happens. Let me set a higher denoise. Yeah, pretty cool. Okay, let's say I like this one and I want to upscale it to fix the small defects. There are many options. The simplest is to upscale the generation in the pixel space and apply a second pass. So I need an upscale image by, change the method to Landscale, scale factor to 2, and connect the pipeline. Next, I send the image to the latent space, connect the VEI, and we are ready for a second K-sampler. I can duplicate this one. The latent is the upscaled image, positive and negative will be the original prompt, and the unit, of course. Finally, a decode and the preview. In the K-sampler, I change the seed, lower the steps a bit, and set the denoise to 0.5. This is basically the simplest high-res fix, and if I generate, I should get a nice 1024 by 1024 image with all the major issues fixed. Yeah, you can see the face is much better and also the shoulder pad. Okay, let's go a bit higher with the resolution. I can try a factor of 3 and retry. And yeah, it still works, but we lack a bit of details. I can try to increase the denoise, but the model is not really trained for such high resolution, and the result will be unpredictable. Yeah, I get this mutant now. The main problem is that the K-sampler has too much canvas and no guidance on how to fill it. To help the disoriented model, I can add a tile ControlNet. So I duplicate the apply ControlNet node, connect positive and negative. We already have the model, and as reference image we use the original generation. Finally, we've got a decent high resolution image out of an SD15 checkpoint. And we can actually go even further. Let me try a 4-time multiplier. Yeah, this is a nice 2K resolution image. We lost a bit of the original colors though, so I can add a color match node. There are many around. This is from the essentials, and if you set the device to GPU, it's the fastest kid in town. As reference, I use the low resolution image, and now we've got that purple patina back. Okay, the resolution is indeed very high and we fixed many of the glitches, but still we didn't add a lot of fine details. To accomplish that, we can do some noise injection. As always, there are dozens of ways to do that. I'm showing you the simplest one. First of all, let me set the resolution multiplier back to 2. Then I need a K-sampler advanced. I connect the model, positive and negative, and the latent from the upscaled image. As per the parameters, I set the same as the standard K-sampler so we can see the difference. Steps 25, CFG7, DPM++ to MSD, and Keras. So this K-sampler will take care of the initial generation, which is the most important. I will run this for 12 steps, that is about half of the generation. Just to see what happens, I'm adding a VEI decode and a preview. Okay, now that we have the halfway generation, I can inject some noise at this stage and finish the image with a second K-sampler. For that, I'm using a noisy latent image node and set the resolution to 1024 by 1024. To merge the noise with our image, I need an inject noise node. I connect the latent and the noise and check the preview. As you can see, the image is now a bit more messy, and that is generally enough to convince the K-sampler to add more details. Before we can do that, we need to set the return with leftover noise option to enable, and this is what will be actually sent to the second K-sampler. If you look close enough, you can kinda see already the shapes. Okay, now I duplicate the K-sampler with all the pipes and connect the noise we generated earlier. Next, I need to disable add noise because we have enough already, and return with leftover noise. The other parameters can be the same, except that we are starting the generation from where we left it at the 12th step. And I can set the end step to any high value, since the generation will stop at 25 anyway. To avoid reiterating on the same concept, I'm also changing the seed. We should be all set. Let's see what happens. Okay, the image didn't change much. Let's try to increase the noise strength to 5. And now we actually added a lot of details. You can see how the armor got a lot of small features. Yeah, very nice. Now I can further fine-tune the generation by changing either the noise strength or varying the start and step. If I lower it to 11, the K-sampler has more time to remove noise and the result will be a little smoother. And if there are some details I don't like, I can always try with a different seed in the second K-sampler. Okay, this is cool, but I want more details. Noise strength 5 is already pretty high, so I'm going to increase the end and start point to 12. Actually, let me synchronize them. I convert the end at in the first K-sampler to an input, and same for the start at in the second. I can double click on the little dot to create a primitive and connect it to the second K-sampler. Now the two fields will always have the same value. Let's give it a try. Okay, perfect. How can we push this generation even further? Well, we can try with tiling. We established that these models work better when they generate images at the resolution they are trained for. This is an SD15 model, so that would be 512 by 512. To try to squeeze every bit out of this image, we can try to subdivide it into smaller chunks and work on each of them separately. So I don't need this first generation. Let me also put the color match back because I like some neon colors. Okay, step 1, we need to tile the image. We can do it one by one with image crop, but it's boring, so I'm using image tile from the essentials. If I connect to the preview, you'll see the image has been split into quadrants. Now, the face is cut right in the middle, and the model might not like that, so I'm adding a 25% padding to the tiles. Okay, now they are perfect. So far we've only used tile ControlNet. To help with the upscaling, this time I'm going to combine tile with depth. I use depth anything v2 that has been just released. I'm upping the resolution to 1024 and check the result. Basically, I will use the depth map for the volumes and tile for the colors. Since we are going to make one generation for each tile, I'm also need to split the depth map. So I'm duplicating the image tile node and connect the depth map to it. At the moment, ComfyUI doesn't support loops, so we have to extract each tile and work on them individually. I need 2 images from batch nodes and connect the tile sets to them. I can connect a preview to check if everything is fine. Okay, perfect. Next, I need to set the ControlNet. I'm adding an advanced ControlNet node, connect the depth map, and select the depth model. Then I duplicate it, and this will be used for the tile ControlNet. I connect the first quadrant, But I don't need a new model because we already loaded tile at the beginning, so I can reuse that. Now for the negative, I'm taking the original negative prompt and connect it to the first ControlNet. For the positive instead, I want more control, so I'm creating a new prompt that I can use to better describe each section. In this case, the prompt is mostly fine, but I'm changing a few words. And this goes to the positive. Now I can connect the two ControlNets together, and for the strength, I'm setting a high value for depth. Let's start with 0.7 and end at 0.9, while for tile I can be pretty loose, strength 0.7 but end at just 0.5. Next, the case sampler. I'm taking the original model pipeline, positive, negative, and for the latent I'm using an upscale image by with a factor of 1.5. And I'm using the first tile as base. Then to the latent space with an encode, connect the VEI pipeline, and to the case sampler. In the case sampler, I'm using a fixed seed as always, 25 steps, CFG6, DPM++2M SDE, Carras, and the noise 0.9. Finally, to the pixel space with a preview. Remember, these are all parameters you can tweak based on the checkpoint and ultimately your own personal preference. We are finally getting some nice details. Look at the difference with the original tile, especially the armor. We got this nice weathering. Okay, fine. Now I'm repeating everything for the second tile. I need to duplicate all these nodes and increment the index for both image from batch nodes. The prompt is fine. I could reuse the previous one, but I'll keep this node. You never know if you want to make some changes. And here we are, tile number 2. And if I don't like it, I can always try another seed or change the parameters. Okay, tile number 3, duplicate everything, change the batch index, and this time the prompt will be close-up of the torso of a cyberpunk woman wearing a sci-fi metal armor. Generate, okay, perfect. And the last one, in the prompt I'm also adding bionic arm, because in this tile the arm is a predominant element. Okay, nice. All left to do is to merge everything together. I'm not sure what size this image is, so I'm using a getImageSize node. Then I need a simple math, connect the width to A, and as operation I write A minus 192 multiplied by 2. 192 pixels is the amount of overlap between the tiles. I add an empty image and connect the int value to width and height. I don't need to repeat the same for the height because I know the image is a square. If I connect the preview, I'll get an empty canvas that will host our image. I'm adding an image composite masked. The destination is the empty image and the source is the first tile. I connect it to the preview and our final image is slowly coming out. For the second tile, I need another image composite. The destination is the image that we are compositing, the source the second tile, but this time I need to move the image to the right. To do that, I can take another simple math, connect the total image size to A and the tile width to B. And the operation will be simply A minus B. Convert X to an input and connect the value from the simple math node. If I connect the preview, everything should be in place. Okay, this works, but we have a very sharp seam where the two images meet. Let's fix that. I need a solid mask, convert width and height to input, connect them to the tile size, Then I need a feather mask node with a feathering of 192 pixels on the left. I can connect it to the image composite, and now the seam is gone. Okay, let me repeat the whole process for the last two tiles real quick. And this is the final composition. Let me also add back the color match. Okay, perfect. Now, of course, this is still too small and there might be some glitches coming from the compositing of the tiles. So we are going to add a final K-sampler. This will be a very light pass, so we need a high quality upscaler. For that, I'm using an upscale image using model. As the name suggests, this node will upscale using a dedicated model trained specifically for that task. There are hundreds of upscale models, and you can find most of them on openmodeldb.info. You can filter by what you want to upscale and also a lot of other parameters. For this image, I'm using Ultra Sharp. That is a good all-around performer. So I need to load the model, select Ultra Sharp, and then I'm scaling it down to 2K with an upscale node. I'm often asked why I use a 4-time upscaler just to scale the image down right after. Well, first of all, I found 4x upscalers to be generally better. But also, when upscaling, the model itself tends to add small glitches, and scaling the image down often gets rid of the imperfections. But anyway, it's just personal preference. Do as you wish, it's your own generation. Okay, next I'm sending the image to the latent space, connect the VAE, and to a final K-sampler. These will have a very low denoise, so the impact will be minimal, just enough to bring all the elements together. We need very few steps, around 15 should be plenty enough. DPM++ to MSD, Keras, and a fixed seed. Of course, I need the code and the preview. And there you go. We went from 512 to 2048. Let's try another seed. Of course, I'm not suggesting using this workflow for day-to-day generations. There are extensions that do most of the heavy lifting for us, like the Ultimate Upscaler or Tiled Diffusion or Superior. But the purpose of this video is to demystify the upscale process. As I always say, this is not magic. If you understand the underlying technology, you'll be able to also use the automated tools better. That being said, this very confused workflow gives you an unparalleled level of control over the generation. You can fine-tune each tile with a dedicated prompt. You can try to use a different ControlNet or add another one like line art. You can inject more noise at this stage to get even more details. Not to mention other optimizations like free hue, deep shrink, or perturbed attention. Okay, back to our image. I applied a final pass to it, but before doing that, we could improve some details. For example, this circle thingy on the shoulder is a bit hallucinated, or I could fix the eyes and add some skin texture. All these things can be done with detailers, and that's just a fancy name for taking out a piece of the original image, upscale it to optimal resolution, apply a second pass, and put it back where it was. This process can be automated for like the face and the hands, or can be done manually selecting the area we want to modify. So today we demystified upscalers. Next time we'll demystify detailers and segmentators. One last thing before I leave. I really don't like how the colors turned out in this picture, and I want to try to fix that with a lookup table. All I need is an image apply loot node. I have downloaded quite a few cube files. For cyberpunk stuff I have this one that is really great, so I'm gonna try that, and I'm lowering the strength because this loot is very aggressive. And look at that, serious badass. Okay guys, I hope you liked the third installment of the basic series. Let me know what you think. See you next time. Ciao.